Hello, good morning, good evening. Welcome to Embedded Systems with Mohammed Dana. That's me, the embedded wizard here in Ghana. So here's my latest project. It's a GPS fix finding project. So you see, recently I moved to a rural area, and it's been difficult finding satellites. And in order to find satellite strengths in different parts of this rural area, I built up this project so that I can get the number of satellites I can find in different parts of the rural area. Yeah, so this is a fairly simple system. Like I said, GPS finding system. We have the U-Blocks GPS module over here. You can see that at Mega 32.8. Oops, sorry. Oh, the screen, the light was too bright for my camera, so it just kind of went off. Oh, sorry about that. But anyway, you can see the Mega 32.8 chip, the oscillator circuits, and the LM7805 power circuits. And here we have our LCD display. It's a 16:2 I2C LCD display. Alright, so what I'm going to do is take you through how I did the design and why I selected each of these components. Yeah, so by the way, this is my programming interface, just connected to this other Arduino board that is supplying this board with power, just 5 volts. Yeah, it's actually 5.5 volts, but it still works within 5 volts. All right, thanks a lot. Let's move on.
All right, let's get started. So I designed the project. I designed the schematics in Eagle Card, as you can see here. It's Eagle Card is really simple and easy to use, and I would always recommend Eagle Card to anyone. Yeah, so here's the power supply system. By the way, here's a view of the entire schematic. So concentrating on we'll start with the power system. It's based on LM7805. Okay, so it was just a prototype, so I did not include capacitors and other filtering circuits. So it's just more or less straightforward. I just wanted to build something that is straightforward and have less, because it's a prototype, so have less components. Yeah, so this is the Atmega 32.8 MCU right over here. Beautiful in it. Yeah, here is the crystal oscillator circuits, 60 megahertz and 22 picofarad grounding. Yeah, beautiful. And here are the connections to the different components. So LCD is connected via I2C to the microcontroller. So we have the SDA, SCL pins connected to the microcontrollers, SDA and SCL, and those pins also share ADC, an ADC functionality, and we've got 5 volts of VCC and ground. Nice. And GPS module. So GPS module we are using a soft serial, so an artificial software enabled UART communication for to communicate with our GPS receiver. Yeah, so this is RX and this is our TX, so that is on pins 3 and 4. I'll show you in the programming later on. And our hardware soft serial is reserved for the programming interface. So for the program interface, to program the chip using an Arduino board, we have VCC, ground, reset, RX, and TX. Yeah, and this is how the board, the components are placed on the board. So this is the layout view. Yeah. So I meant this side. Yeah. So you can see that I drew this area purposely for the LCD display, and this area purposely for the GPS modem, or the GPS module, sorry, and the programming interface. Yeah. So these are the individual connections, as we can all see, and in order to put copper layer, yeah, so now this is copper layered, so meaning that we've got copper all over, and the individual connections have been isolated. This is very good because of thermal dissipation. And one other thing I would like to show you is, I think this, yeah. So this is an example of how the board would look like. So you can see our chip placement, crystal oscillator, ceramic capacitors, and all that. Isn't she a beauty? Let me open this up a bit. Yeah. Nice, eh? Alright, so let's go to why I selected some of the components. So we're going to start with LM7805. So with the LM7805, it's a common hobbyist linear voltage regulator. It has some inefficiencies, but good for prototyping. So we are currently accessing the data sheet so that we see its specifications. Oh, network is slow. This might take some. Okay. All right. Nice. Okay, let's download. All right. Okay, it opens at the bottom here. So this datasheet is for general LM78 series, and the total outputs that they can the total current output that they can do is 1.5 amps, tolerance 5%, and these are the output voltages. They also correspond with the different types of linear voltage regulators made from the same company. So we can have different characteristics. So output, this for LM7805, output voltage maximum is 5.2, minimum is 4.8, and typical average is 4.5. Now operating temperature, okay, the linear regulation, okay, load, so this is a maximum output, I guess. Yeah. And let's see if we have recommended circuits in this datasheet. Alright, so this particular datasheet doesn't have what I am actually looking for. So let me try a different one. Yeah, Texas Instruments. Nice. All right. All right. So yeah. So this is what we saw in the other data sheet. So that is 1.5 amps, and yeah. Oh, sorry. Oh, interesting. Okay, so this includes other linear voltage regulators. So yeah, so this is an example of recommended circuit connection. The input were recommended to use capacitors, and the output were recommended to use capacitors as well. And yeah, so they come in. Let's see. So they come in these forms. So this is the form that we're using, the TO 220. Sorry. Yeah. So there's a lot of information, and this should guide your design of whatever embedded system. This is the internal diagram of the LM7805 or LM78 series. So depending on the voltage outputs, a couple of transistors, internal circuitry would change. Yeah, so these are recommended application of information. So however you want to design your system example. Let's see. All right. So data sheets are very, very important. They guide your design analysis and how you're recommended to design whatever system, whatever embedded system. Yeah, so feel free to come and check this whenever. So next stop is Atmega 32.8. Alright, so Atmega 32.8 is a very common microcontroller. It's an 8-bit microcontroller and is commonly used in the Arduino, on the Arduino board. So you can simply upload the bootloader onto the Arduino board or onto the Atmega 32.8 and use Arduino libraries to program the chip. It makes life much easier, or a lot easier. Right. So okay, so let's open up this from Atmel. Atmel designed this chip, this beautiful chip, 8-bit, and I think Microchip bought Atmel. So now the IP belongs to Microchip now, and Microchip is famous for their PIC microcontroller series. Alright, so the network is a bit slow. Let's wait a while. Beautiful. Yeah, so low power 8-bit microcontroller. So this is what I'm really interested in, low power. Whereas with the system, it means that I can work with really low voltages below 5 volts. So we can check and see the voltage range. Yeah, so speed grade. Yeah, so I can work so between 0 to 4 megahertz, I can work between 1.8 to 5.5 volts. Now 0 to 10 volts megahertz, I can work within 2.7 to 5.5 volts. So between 0 to 20 megahertz, I can work within a range of 4.5 to 5.5 volts. Yeah. So meaning that if I am to use probably a crystal oscillator rated at probably around 4 megahertz, I can work as low as this voltage, 1.8 volts, and as high as 5.5 volts. So this datasheet has got a ton of information, and these are the packages that the microcontroller comes in. Yeah, so these 3 packages are SMD package types. This is DIP packages. This is the internal system diagram, the internal block diagram. It could also help guide your design. It would help guide your design. So instruction sets, in case you want to use assembly to program this microcontroller, you can easily use assembly. A big deal. Beautiful. Alright. Okay, so for this family of for Artmaker 48, this is P and this is the power supply and that. Nice. Huh. So let's look at. Yep. So at this, okay. So at 20 megahertz, we can still work within 1.8 to 5.5 volts, and this is the industrial operating temperature. So I can work in temperatures as low as minus 40 degrees to maximum of 85 degrees Celsius. Awesome. Not bad. Yeah, not bad. You can also have other pin details and so data sheets are really important so that they guide your how you would want to design your system, and gives you a lot of details as to what the specifications of the components that you might be using. Yeah, so next up is GPS module. The GPS module is the GPS module we are using is the new the U blocks. Yeah, 7M GPS module. Awesome. So ideally from the manufacturers, this is how it comes. But when you buy from retailers, it comes with its breakout board. Oh, and one other thing is that new 7M is now old. It's an older generation. So the latest ones are HQ module and a MHQ series. We'll have to migrate to them later on. So anyway. So you could also design your own breakout board according to the pin configuration and according to specifications from the data sheet. So so this is the data sheet. Let's click and get some information or read out some information. Yeah, so this is the data sheet available to us, and yeah. So it works with 56 channels, GPS, design important information that you might need to for operations, a certain kind of operation that you want to activate, deactivate, or whatever. Yeah, so oh, these are operational limits. I like this. So because anytime, let's say the device is on a gets to be built on probably a rocket or a drone or something, this information right here should guide you as to the specifications. So probably you're going beyond say 10G or something like that. This might not be useful to you. You might need something different. Or if you're going at the velocity beyond 500 meters per second, then this might not be ideal for you. You may need a different one. Else, if it's below those specifics, then this is certainly the best GPS module for you. There are other informations that will guide you in case you want to design your own probably breakout board or whatever system. So guidance navigation, I mean, let's name it guidance navigation, GNC systems, or whatever. So you have all this beautiful information. You can actually access, nice, you can actually interface with UART. Yeah, well, we are actually using UART communication, but you can also use USB SPI. Nice. And display data channel. I haven't worked with this, but I'll be glad to do so. Yeah, so this is beautiful. And oh, nice. Yeah, absolute maximum ratings. Okay, I'm a bit skeptical about the minus voltages. Let me scroll now to operational conditions. Yeah, so power supply voltage, yeah, minimum 1.65, maximum is this. So on the breakout board, let me show a picture of this. U blocks. Yeah, so on this breakout board, as you see here, we've got all types of circuits such as linear voltage regulators that would step down voltages from 5 volts to say, sorry, so that will step down 5 volts to say 3.6 volts. That's the maximum, or probably in between. It could be 3.3 volts or something. Yeah. And we've got all types of protection circuits for like fuses and capacitors, all that. So whatever you read inside, whatever information is here, it would guide you as to how to design the breakout board, which is this. Or you could just simply buy this breakout board and integrate it to your own board. That's your choice. Yeah. And next up is our LCD, 16 by 2 LCD display. Okay. So whenever we say 16 by 2 LCD display, it means that it can display 16 characters on 2 lines. So this one line and this is another line. So 16 characters over here, down there. Yeah. So 16 characters up and down. And it comes in. I've seen 2 varieties so far: blue and green or yellow. Yeah. So ours is I2C communication protocol. So I2C communication protocol actually simplifies our work like magnitudes. So instead of connecting all these pins to the microcontroller, we simply integrate it with this I2C interface, and voila, we just connect these pins instead. So we have ground, so like we have over here. Let's come to this board. Oops. Yeah, sorry. So we have ground, VCC, SD, and SCL. Yeah. That makes makes life very simple. Yeah, so let's check out the program. So I wrote the code in Arduino using Arduino libraries. It's C++ based, by the way, and because it's much easier, it's a lot easy. Okay, download not right now, probably later. So just like any other C++ coding structure, you have your libraries. You start calling your objects, it's initializing objects in classes, initializing communication, LCD initializing, and others. Yeah, and then we start the communication, waiting for GPS data to come in. Whenever there's GPS data, we send the data into an encoder within the GPS library that will then grab and extract the number of satellites that we want, the latitude and longitude. Yeah, and over again. Yeah, so the code is really simple. I'll make it available on GitHub pretty soon. And one other thing is, here's our soft serial. This is actually for the GPS communication. So you can see that I'm connected to pins 3 and 4. And right over here is the address, the I2C address line that the LCD is connected to, and we are telling the LCD library that we are communicating, that is, we're going to communicate or making use of a 16x2 I2C. 16x2 LCD. Yeah, real simple, no difficulties. I will put the link to my GitHub so that you can have it and go through. Alrighty, so thank you very much for your time. Bye bye.